Our universe is a vast and mysterious place. It's full of incredible events. These events are so powerful they boggle the mind. Imagine explosions brighter than a billion suns. We call these cosmic events. They are supernovae, gamma-ray bursts, and quasars. Get ready for a journey into the universe's most powerful events.
Stars are born, they live and they die, but some stars don't fade away quietly. They explode with incredible force. We call these explosions supernovae. A supernova happens when a massive star runs out of fuel, its core collapses and then explodes outward. The explosion is so powerful it can outshine an entire galaxy. Supernovae are important. They create elements like iron, gold, and even the calcium in our bones. These elements are scattered into space. They become part of new stars, planets, and even life. After a supernova, something is left behind. It could be a neutron star. Neutron stars are tiny and incredibly dense. Imagine a star heavier than the sun squeezed into a city. Some supernovae leave behind black holes. Black holes are even stranger than neutron stars. Their gravity is so strong nothing can escape, not even light. Imagine a giant vacuum cleaner in space, sucking up everything around it. Neutron stars and black holes are extreme objects. They help us understand the limits of physics.
Gamma-ray bursts, or GRBs, are the most powerful explosions in the universe. They release more energy in a few seconds than the sun will in its entire lifetime. Imagine a billion trillion suns exploding at once. That's the power of a GRB. GRBs are short but intense bursts of gamma rays. Gamma rays are the most energetic form of light. They can be detected from billions of light years away. These powerful explosions are still a mystery. We are learning more about them with powerful telescopes. Section 5. Short GRBs, a cosmic mystery. There are two types of GRBs, short and long. Short GRBs last for less than 2 seconds. We think they happen when two neutron stars collide. Imagine two incredibly dense objects smashing together at almost the speed of light. The collision sends out a powerful burst of gamma rays. Short GRBs are still mysterious. We don't know everything about them, but they hold clues about the nature of gravity and the densest objects in the universe. Section 6. Long GRBs, birth cries of black holes. Long gamma-ray bursts, or GRBs, are among the most powerful and enigmatic events in the universe. They are like cosmic beacons, signaling the birth of one of the most mysterious objects in space, black holes. Long GRBs last for more than 2 seconds. This might not sound like much, but in the realm of gamma-ray bursts, it's a significant duration. These bursts can release more energy in a few seconds than our sun will emit in its entire 10 billion year lifetime. We think they happen when a massive star collapses into a black hole. Imagine a star many times the mass of our sun, reaching the end of its life. Its core collapses under the force of gravity, and in a fraction of a second, a black hole is born. As the star collapses, it releases a jet of energy. This jet is incredibly powerful, traveling at nearly the speed of light. It punches through the outer layers of the star, creating a spectacular display of energy. This jet is so powerful it can pierce through the entire star. The energy released is so immense that it can outshine entire galaxies for a brief moment. The jet creates a burst of gamma rays that we can detect on Earth. These gamma rays travel across the vast expanse of space, reaching our planet and providing us with a glimpse into these cataclysmic events. Long GRBs are like birth cries of black holes. They are the universe's way of announcing the creation of these enigmatic objects. Each burst tells a story of a star's death and the birth of a black hole. They tell us that black holes are being born in distant galaxies. These events are not just local phenomena, they happen across the universe, in galaxies far, far away. By studying these bursts, we learn more about the life cycles of stars and the formation of black holes, deepening our understanding of the cosmos.
Section 7. Quasars beacons from the early universe. Quasars are among the most fascinating and mysterious objects in the cosmos. They serve as brilliant beacons, illuminating the vast expanses of space and time, and providing us with a glimpse into the early universe. Quasars are the most luminous objects in the universe. Their brightness is so intense that they can outshine entire galaxies, making them visible across billions of light years. They shine brighter than entire galaxies. Imagine looking up at the night sky and seeing a single point of light that is more radiant than all the stars in a galaxy combined. Imagine a trillion suns packed into a region the size of our solar system. This is the extraordinary power of a quasar. The energy output of these objects is so immense that it defies comprehension. That's how bright a quasar can be. Their light travels across the universe, reaching us from distances so vast that it takes billions of years for the light to arrive. Quasars are powered by supermassive black holes. These black holes lie at the centers of galaxies and are surrounded by swirling disks of gas and dust. These black holes are millions or even billions of times more massive than our sun. The gravitational pull of these colossal objects is so strong that it can draw in vast amounts of matter from their surroundings. As gas falls into the black hole, it heats up and emits an incredible amount of light. The process of accretion, where matter spirals into the black hole, generates tremendous energy, causing the gas to glow brightly. This light is what we see as a quasar. The light from quasars can tell us a lot about the early universe, including the formation and evolution of galaxies. By studying quasars, astronomers can learn about the conditions that existed when the universe was young, providing valuable insights into the history of our cosmos. Section 8. Supermassive black holes, the engines of quasars. Supermassive black holes are some of the most fascinating and powerful objects in the universe. They reside at the centers of most galaxies, acting as the gravitational anchor that holds these vast cosmic structures together. Supermassive black holes are at the heart of most galaxies, including our own Milky Way. These colossal entities have masses that can be millions or even billions of times that of our Sun. The one at the center of the Milky Way, known as Sagittarius A*, is a prime example. These black holes are surrounded by a disk of gas and dust. This disk, known as an accretion disk, is formed from material that is gradually being pulled in by the black hole's immense gravitational pull. The material in the accretion disk spirals inward, heating up and glowing brightly as it gets closer to the event horizon. As material falls into the black hole, it releases a tremendous amount of energy. This process is incredibly efficient, converting a significant portion of the material's mass into energy, which is then emitted as radiation. This energy can outshine entire galaxies, making the region around the black hole one of the brightest objects in the universe. This energy powers the quasar. Quasars are the extremely luminous centers of distant galaxies, powered by supermassive black holes. The energy released by the accretion process is what makes quasars so bright and visible across vast cosmic distances. Quasars are like cosmic lighthouses. They shine with an intensity that can be seen across the universe, acting as beacons that illuminate the dark, distant reaches of space. Their light travels billions of years to reach us, providing a window into the distant past. They are so bright we can see them from the furthest reaches of the universe. The light from quasars allows astronomers to study the conditions of the early universe, offering clues about the formation and evolution of galaxies over cosmic timescales. They provide us with a glimpse into the early universe when galaxies were first forming. By studying quasars, scientists can learn about the processes that shaped the universe in its infancy, helping us understand the origins of the cosmic structures we see today. Quasars are not just fascinating objects, they are also invaluable tools for probing the history and evolution of the cosmos.
Section 9. The Interconnected Universe. Supernovae, GRBs, and quasars are all interconnected. They are all powered by extreme objects and events. They all release vast amounts of energy, and they all play a role in the evolution of the universe. Supernovae create the elements that make up planets and life. GRBs signal the birth of black holes, and quasars illuminate the early universe. By studying these powerful events, we can learn more about the universe and our place in it.
Section 10. Conclusion. A universe of wonders. The universe is full of amazing things. Supernovae, GRBs, and quasars are just a few examples. These events are powerful and mysterious. They remind us that there is still so much out there to discover. So keep looking up at the stars. You never know what you might see. The universe is full of wonders waiting to be explored.